In this video, I'll be discussing how to calculate the reaction quotient Q for an equilibrium reaction. So for these kinds of questions, you'll be given concentration values for your reactants and products in your reaction. And you'll be asked to use those concentrations to calculate the reaction quotient Q. And you'll use your value for Q to determine whether or not your reaction is at equilibrium or whether it's favoring a particular direction. And you're going to do that by comparing your value of Q to the equilibrium constant for the reaction. So in this question, we've got this reaction. Hydrogen gas reacting with iodine gas at equilibrium with hydrogen iodide gas. And the equilibrium constant is 57 for this reaction at 700 Kelvin. So the question gives us these concentrations, and we need to use these concentrations to calculate Q. So let's go ahead and look at how we would set up our equation for Q. So this would be your generic setup for Q for this reaction. We've got the concentration of HI squared divided by the concentration of H2 times the concentration of I2. And we're going to go ahead and plug our numbers in from the question to solve for Q. So the concentration of HI is given as 0.007 squared divided by the concentration of H2 is 0.023 and the concentration of I2 is 0.045. So go ahead and solve for Q using these numbers. So you should get 0.047 after you do that calculation, and that's going to be your value for Q. Now we have to judge Q based on the equilibrium constant K to determine whether our reaction is moving forward, moving backwards, or if it's at equilibrium. Let's look at those different scenarios now. So here are the three different scenarios for your K and Q values. If K is bigger than Q, the reaction is moving in the forward direction. If K is smaller than Q, the reaction is moving in the reverse direction. And if K is equal to Q, that means your reaction is at equilibrium. Well, in our circumstance, our equilibrium constant is 57, and our Q value is 0.047, so it's pretty obvious that K is much bigger than Q. So this is the scenario we're looking at for our reaction. So based on the concentrations we were given, our reaction would be moving in the forward direction.